Okay. Briefly, complex fractions. Excuse me for a second, I do need to zoom this back a little bit. Now, once we get blurry, there it is. Okay. That's a little better. I think I can move this over. Well, anyhow, here we go. A over B divided by C over D means A over B divided by C over D which is equal to A over B times D over C, because division is the same as multiplication by the reciprocal. We've dealt with this earlier, of course. It shouldn't be new or surprising. Which equals MAD over BC. Simple enough, isn't it? Now you have to understand that division by a fraction is multiplication by its reciprocal. You should understand why. But I'm not going to get deeply into why. If you understand why, you're going to be more reliable in using it and do better with it. So work with that idea. Now, that works easily for numbers. I'm going to ask you to do it for something a little more complicated. This is an example. So write that out step by step. Here's just the same thing I've got. A is like x minus 3, B is like x minus 7, and so forth, right? Write out all my words. And write out every step of this. And see what you end up with. I have to say that most of you didn't do what I said, even though most of you got the right answer, not everybody. Okay? I said write it out exactly as I did with all the words. Did anybody write the word means? Raise your hand and jump up and down and congratulate yourself if you did. Well, nobody is jumping up and down. Nobody is raising their hand. Okay? When I say write it out, there's a reason for that. The reason is I want you to understand the logic of it and not just write it out without understanding the logic, even though you probably do understand it. Okay? You learn more that way. Worth doing. I'm not mad at you for not doing it, but I'm a little concerned that you ignore that part and you just write down a bunch of symbols and hope they're right. And in almost every case they are. Okay, so anyhow, here we have it. Of course, I might have misled you by starting off with an equal sign here instead of the word means. So I'll take responsibility for that, but think about what I just said. Okay, so this means, well, I can tell you about there, I'm going to go up here. Okay, this means means this, which is equal to what? To do the reciprocal here. Not everybody did that. Okay. So you might have missed that. But this is C over D and this is D over C. You want to be very careful to make sure you get all the symbols in the right place. Otherwise, you get off to the wrong start, and then it's harder to correct it. So be very careful. And then equal. Now, when you go ahead and expand the numerator and the denominator, in other words, use the distributive law on the numerator and use the distributive law on the denominator. And write out the steps of the distributive law explicitly. Okay. So I say, what I mean, you don't have to write out those words, although you may if you wish. When I say use the distributive law, what I really want to see, again, for the sake of your learning process, is that this times this is x times x minus 5 minus 3 times x minus 5 divided by x times x plus 2 plus 7 times x plus 2. Distributive law, this times this is this times this minus 3 times this times this, okay? Then this times this is this times this plus this times this. If you don't automatically understand the distributive law and how to write this out, begging you, please get to the mark and get some help. Okay? We've done it. We've written these things out many, many times, and many of you are not writing it out. Now, some of you are doing this thing. Which is equivalent to the distributive law, but it's not the distributive law. And gets more confusing when your expressions get longer. It still can work if your expressions are longer. And it's not a bad way to look at it. But you need to be able to go back to the law to make sure, because otherwise there are places where you're going to get insecure with it, and it's not going to work. Of course, in those places, you're likely to make clerical errors, because there's just a lot of stuff about that. Okay? So still, I should probably do it both ways. Write the thing out and then do this. See if they agree. That's one way to check yourself, see if you've done it right. Anyhow, be able to do that. So we get this. And that's then, of course, x times x minus x or plus x times negative 5. Okay? And that's minus 3 times x minus 3 times negative 5. That's divided by x times x plus x times 2 plus 7 times x plus 7 times 2. And it will come up here. That's equal then to x squared minus 5x minus 3x plus 15 over x squared plus 2x plus 7x plus 14. Then equal to x squared minus 8x plus 15 over x squared plus 9x plus 14. Ponder that if you need to. I'm going to take a quick look at something. Okay. Now I'm going to digress to long division. This is how you simplify a complex fraction with where the numerator, denominator are expressions, algebraic expressions. And if they happen to be polynomials, which they're going to be in this course, then you need to understand how the distributive law and everything works with polynomials. And you need to understand the distributive law forward and back. Now you have the assignment on factoring monomials, right? And you should understand how that's just using the distributive law back. It's finding out how we could write this expression as this times another expression using the distributive law. Hopefully you understand it in that way. We'll talk about factoring trinomials in a few minutes. Maybe. Let's look at long division. Okay. So here, I want you to divide x squared minus 8x plus 15. Actually, I'll do it for you, but we're going to divide this by x minus 3. Okay. This will illustrate the general idea of long division. Okay, well, there it out like this. X minus 3 is divided into x squared minus 8x plus 15. Now I'm going to do the reasoning of this, but there's the process also, which Open Math I think has done a pretty good job because people that did the homework did pretty well. Okay, but x goes into x squared how many times? Well, that means what do we put here? So if we multiply it by x, we get x squared. Well, clearly, if we want to multiply something by x and get x squared, that something has to be x. So I'm going to put x here because x times x is x squared. Then I'm going to multiply this by this using the distributive law, x times the whole x minus 3, which is going to give me x squared minus 3x. Now we've got our x squared. Well, if we subtract x squared from x squared, we're going to get 0, right? And I believe Open Math tells you that you kind of put a little negative sign here because we're subtracting this, right? So x minus x squared gives us 0. And negative 8x minus negative 3x is the same as negative 8x plus 3x. So we get a minus 5x. Okay. Because negative 8x plus 3x is negative 5x. 0 is just 0, so we don't really need it. So I'll kind of rub it out early this morning there to show that it was there once. But now we don't have to worry about it. Okay. Now, what do we put here to multiply x to get negative 5x? Well, clearly, if we put negative 5 here, negative 5 times x is negative 5x. And negative 5 times negative 3 is what? Plus 15, right? Now, we can really bring down this 15 here, although we could look all the way up here if we wanted to. But Yeah, really told to bring down that 15. It's just like the long division algorithm you learned in 5th grade. Although you probably haven't used it much since then, it might be a little less. But it's a 5th grade topic. Again, if you don't know how to do long division with numbers, it's a no. Okay. So negative 5x plus 15, negative 5x plus 15. Well, we're going to subtract all this, which means that we're going to subtract negative 5x, which means we're going to actually be adding 5x. Then we're going to subtract the 15, which means we're going to be adding negative 15, which gives us 0 plus 0, meaning that we're done. Okay. What's this tell us? It tells us, just like in long division, if you divide this into this, the result is going to be what you multiply by this to get this. So this multiplied by this has to equal this. And of course, we know that's true because we just worked it out. So now I want you to use long division. X plus 2 into x squared plus 9x plus 15. Okay. Now, people did pretty well with this. There are a few little glitches. So you need to understand the logic of what's going on. Okay. Of course, if you're missing things, you need to take a good look at open math and the problems and ask yourself how you got the problems right. If you did the homework, just most people who did the homework got most of the problems right without following the steps. Okay. Okay. Well, again, we're going to need x here. X times x gives us x squared. But we're multiplying x by the whole x plus 2, right? Because in the long division algorithm, you multiply whatever you have here by whatever you have here. What we have here is an x plus 2. So x times x plus 2 gives us x squared, but then we have to do the x times 2 because that's a distributive law. And now I write down little tiny positive and negative signs here. Maybe even put parentheses around them. It might not be a bad idea. So we're actually going to do x and a negative x squared and a 9x and a negative 2x, which is going to leave us with 7x. And then we're going to need that 15 to match up whatever we multiply by 2. Okay. Then x goes into 7x 7 times. So now 7 times x plus 2, 7 times x is 7x. 7 times 2 is 14. I think people wanted to write down 15 here because you're imitating what you see over here. Okay? You're imitating what you see over here rather than thinking that multiply this by this. Okay, imitation, you have to do some of that. Okay. That's how most people begin learning, but you gotta get beyond the point of imitation. What I said here is you multiply the -5 by the x minus 3. That's what gives you the 15 down. You don't get a 15 down here, it's because I have a 15 up here. If I put 30 up here, I'd still have a 15 down here because of the way these multiply. And because here, you got a 15, just like we did here, wasn't really trying to trick you, but maybe a little bit, okay? You're following the process. Process is you multiply this by this using the distributive law. That's what you write down here, and then we proceed to subtract this thing, which means you might want to put negative sign here in parentheses and the negative sign here in parentheses for some indication, which is going to give you 0 plus 1. Now that didn't end up with 0 plus 0. It didn't divide in evenly the way you would say it with real numbers, okay? Real numbers, you get a remainder, okay? The remainder is 1. And what do you do with the remainder? Well, you can write this as this with the remainder of 1. You probably learned to do that in 5th grade. Probably forgot about it if you didn't use it sometime. Okay. Or instead of writing remainder 1, remember you can write 1 over whatever this is. Whatever your remainder is divided by this, because we have to divide this into 1, right? We divide this into 1, that means we have 1 divided by x plus 2, which we can write down as plus 1 over x plus 2. Now we can check our work. Multiply that for me, use the distributive law. If we multiply this, there are 2 ways to write the first step of the distributive law here. And different people are writing it in different ways, and both ways can work. So the more common way I've seen is you say, okay, because this is the way I've written most things. You can write this as x times x plus 7 plus x times 1 over x plus 2. So multiply x by this, multiply x by this. That's your distributive law. You've written down. Well, there's another way to write it down. But then you have plus 2 times this and 2 times this. So that's 2 times x plus 7 plus 2 times 1 over x plus 2. Okay. Now, x times x plus 7 is x times x plus x times 7. And x times 1 over x plus 2, I mean, I could write that as x over 1 times 1 over x plus 2. That's going to give me x over x plus 2. Again, that's something we've done earlier in the course, so make sure you understand this. And then it's plus 2 times x plus 2 times 7 plus, again, we can write that as 2 over 1 times this. We multiply numerators and multiply denominators just as we did here. we're going to get 2 times 1 is 2, and 1 times x plus 2 is just x plus 2. Now this equals x squared plus 7x plus 2x plus 14 plus x over x plus 2 plus 2 over x plus 2. And then very clearly, we get our x squared, our 7x and 2x add up to 9x. And x over x plus 2 plus 2 over x plus 2, we've got the same denominator. We can add these numerators. And we get x plus 2 over x plus 2. So that equals then x squared plus 9x plus 14 plus 1. X plus 2 over x plus 2 is 1. Which is x squared plus 9x plus 15. And we notice that that's what we had better get. When we divide this by x plus 2, we get x plus 1 plus 1 over x plus 2. If we then multiply this by this, we should get this. And we do. Now, what other way of doing that? Alternative distributive law. I could distribute over this plus sign, right? So that this times all this is this times this chunk plus this times this chunk. So this gives us x times x plus x times 7 plus 2 times x and I'm writing out, I'm skipping a step here, but I don't want to do that. I apologize. I'm going to come out with what I said, but this equals x times x plus 7 plus 2 times x plus 7 plus, well, this is x plus 2 over 1 times 1 over x plus 2. The x plus 2 multiplies the 1 to give you x plus 2, and the 1 multiplies the x plus 2 to give you x plus 2. Okay? And that means that we don't have to notice that we can add these two fractions here to get this, which gives us 1. It gives us the 1 immediately. It's a little easier to get the 1 this way, but you should be able to do it either way. That's x times x plus x times 7 plus 2 times x plus 2 times 7 plus 1. Which then equals x squared plus 7x plus 2x plus 14 plus 1, which is x squared plus 9x plus 15. So we have a choice of multiplying out using the distributive law, distributing over this plus, which means we do x times all of this, and then plus 2 times all of this, which is what we did here. Or we could distribute over this plus sign, which gives us what we have here, this times this, plus this times this. Okay, we're going to talk about factoring trinomials. And right now, we're factoring mono. I know this. I know by the distributive law that this is going to equal x plus something times x plus something. And I know whatever numbers I put here have to multiply out to give me 15. Okay? Because if I multiply x plus a number times x plus a number, those two numbers multiply to give me a number, and that number has to be this number here. Anything else is going to be multiplying x. This number multiply x, this number multiply x, and so forth. Okay? But the only way we get a number is if this number times this number. So we want to see what these two numbers might be. Well, what numbers can we multiply to get 15? Actually, there are infinitely many possibilities. You know, 1/2 times 30. Okay. But we want to factor. Usually, when we factor, we want to do it in terms of whole numbers or integers. So what times what equals 15? Well, I know if I multiply x plus 15 by x plus 1, I'm going to get 15 out there, right? Okay. That doesn't mean that when I multiply these out, I get this. But it equal this though. What could it equal x minus 15 times x minus 15, x minus 1? Could it equal this? Okay. Could it equal x plus 3 times x plus 5? Or could it equal x minus 3 times x minus 5? In each case, the number that we get, the number doesn't have any x's on it, is going to be this times this, right? And this times this is 15, this times this is 15. This times this is 15, and this times this is 15. I'm going to say, if this factors, one of these will work. I'll say that, but if this expression factors over the integers, one of these got to work, right? Because these are the only pairs of integers that multiply out to 15. Now, if I gave you a number like 36, which has factors of 1, 2, 3, 4, and 9, and 6, okay? You'd have half a page full of possibilities. And at that point, you'd want to start using a little common sense of which ones you reject, which ones you accept. And you have to start doing a little mental arithmetic. However, in this case, we can list all the possibilities and check them out one at a time. Well, x plus 15 times x plus 1, and I'm not going to write out the details of the distributive law on all of these, but I'll probably go ahead and write it down here. Okay, now we want to look closely at this expression. And we see that 15 times 1 is going to give us 15, which is no surprise because we wrote these numbers down so they give us 15, right? And of course, I knew that it was going to be an x here and an x here because the x times x that we get is going to give me x squared. Okay, so I got 15 because these two numbers are all, each pair of these numbers multiplies out to 15. Okay. Now here I have to add 1x and 15x. I could write that as 1 plus 15 times x. That's distributable. I just factor out the x, right? I write it this way because when I look at this, it tells me how the 1 and the 15 go together to give me this. Okay? By the distributive law, you can trace the fact that I'm going to have 15 times x and I'm going to have 1 times x. Now, at this point, open math is probably going to tell you about, I hate to use this kind of language, this F word. I mentioned it in here. I don't even like to repeat the thing, but it starts with L, 4-letter word, and it ends with L. What 2 letters go in here? Okay. FOIL comes down to this thing that everybody so much loves to do. Okay. I don't like it. Maybe I don't like it because nobody ever heard of it before I was in at least graduate school. Okay. Didn't start becoming popular. It's a shortcut that bypasses understanding of the distributive law, which leads to the fact that people continue to misunderstand the distributive law. It also only applies to factoring binomials. Now, factoring binomials is important. Okay. So it's a one context in which I will accept this thing. Okay. I don't like it, but I have to admit that it's probably helpful, and open math is going to use it like crazy. Okay. So I don't want to contradict open math. I don't like the thing, but there is a point to it, and most authors use it, including the authors that think are great authors. I hope some of them use it, but have to grit their teeth before they'll actually write it. But that's just my opinion. As I say, there is an argument for using it, as long as it doesn't get overused. Okay. So anyhow, we see that this doesn't work, and we see that this number and this number add up to give us a coefficient of x. It's easy to see why. I mean, here's this number times x, and here's this number times x. So we have this number times x and this number times x, which gives us the sum of those two numbers times x. Using that idea, we see that this isn't this, right? So we have a 16 here, and we have a negative 8 here, so it doesn't work. So we cross that one out. Okay. Now, if we do the same thing here, this gives us x squared minus 16x plus 15. And again, the minus 6 doesn't work. Minus 16 doesn't work. So it doesn't match the 8. So we cross out this possibility. And then we check out this possibility, which is x squared indicate how these correspond. This is going to give us x squared plus 8x, oops, plus 15. Well, this has a plus on the 8, not a minus. Okay. But it means we're getting 1, because we get a plus here, we can get a minus. Think about why that's true. But it doesn't work. But this one, which I intentionally saved for last. So you want to make sure you understand why this works. But the bottom line is that the -3 and the -5 add up to -8. Just like the 15 and the 1 added up to our 16 here. And if you work out the truth law, you see why the -15 and the -1 add up to -16. Line through the minus sign. You see what I was crossing out. Okay, and the 3 and the 5 add up to 8, and the -3 and the -5 add up to -8. This is the one that matches. And I just put an X on that one, but this matches. So this works. Okay. Of course, we know that because all the way back here, we use the distributive law to multiply x minus 3 by x minus 5. And we got x squared minus 8x plus 15, right? So this is how we work it backward. We have to understand the distributive law and understand what we're doing in either case. But it comes down to something pretty simple when you have a monic trinomial. And monic means you just have a 1 in front of your x squared. So you don't have to worry about putting other numbers in front of some of these x. Okay, well, that's going to be an important skill in your pre-calculus class. It's going to help you understand.